So today we'll be learning more about algebraic manipulation. So before, in the previous video, we just looked at the identities, and that video was pretty simple because it was just the identities and just showing like which kind of expressions can be related to each other. But we didn't really apply them, though those identities are very important, but it's not well known by people starting competition math. So it's important to get used to using those. So we're going to be using those in this video. So the first question is, we'll have a question first. So we want to find m cubed plus 1 over m cubed, given that m plus 1 over m is equal to 2. So before I just set you off to try the problem on your own, I'm just going to give you a hint. I'll give you the identity that you need to use. If you remember, so if we said this is x and this is y, then we will have this. So you will have this as the expression, and so this will be the identity that will give you the answer quickest, I feel. So I'll just tell you the steps. So we know we have to find this. So we have to find this, and we know this, and this just becomes 1. This just becomes 1, but this just becomes 1. But what about? Oh, wait a second. That is not 1. That is... that is 1 over m squared. Yeah. So this is just 1. This is just 1. Then what is m squared plus 1 over m squared? So if we find m squared plus 1 over m squared, then we're going to be able to find... and we can just plug 2 into here, and then we'll calculate the value for m cubed plus 1 over m cubed. So we just need to be able to find m squared plus 1 over m squared, and you can try that on your own. So I'll just give you, so pause this video and try the rest of the problem by yourself. So the solution, so all we need to find is m squared plus 1 over m squared from the given conditions, which says m plus 1 over m is equal to 2. So we're going to try that. So if we think about, so if we let m and 1 over m be x and y, then can we use x plus y to find x squared plus y squared? Well, that's not enough information, but we know that we know what x times y is, because m times 1 over m is equal to 1. So we know x plus y, we know x times y. Then if we think about an identity from the first video that on algebraic manipulation, we know that there is an identity relating x plus y, x times y, and x squared plus y squared. So we're going to use that. So m plus 1 over m squared is equal to m squared plus 1 over m squared plus 2 times m times 1 over m. And therefore m squared plus 1 over m squared plus 2, because this just cancels out, and this is 2 squared, which is 4. Therefore m squared plus 1 over m squared is equal to 2. So we found m squared plus 1 over m squared, which is very neat because we can just plug it into this formula. So this is just 2. M squared plus 1 over m squared is 2, minus m times 1 over m is 1, which is equal to 2. So that will be our answer to this problem. So we can see that in the second video doing problems using the degree 2, using the quadratic identities, it was much simpler. The steps were it was almost just one step. You were given this, and you were given one expression's value, and then you could find, and then you could find another expression. You had to find the value of another expression's value. Like most of the problem we did, we had to find the product of them, product of the two numbers. In this case, m times 1 over m, it gives 1. So, but like that's really quick observation. But in this case, we had to take the further step of seeing that, oh, we don't know what m squared plus 1 over m squared is. We know this, but if we just know what m squared plus 1 over m squared is, then we can find m cubed plus 1 over m cubed straight away. So will there be a way to find m squared plus 1 over m squared? And by our knowledge of those identities, we were able to do so. So here you can actually kind of see the importance of being well equipped with these identities in your head, so that you can just take them out and use them and not only use them, but have them at the back of your mind, so that you can see if it's possible to find certain values using the given conditions. So yes, that was a simple problem, and now we're gonna try a bit more mixed problem. Not mixed, but less simple than this. So the problem is, now I'll just give you the given conditions first, because I think that will make more sense. So we're given that 1 over a minus 1 over b minus 1 over a plus b equals 0. The problem asks you to find this. So this looks a bit strange because we don't know anything. We don't know what to do with this. This is the problem. So, but we see that this may have something nice, because we know that, remember, we did a few problems on just now as well, like with m and 1 over m. So numbers that are reciprocals of each other. And if we have a symmetric expression with them, then it's nice because their product is 1. So we know their product. So maybe we can use their product and any other given conditions to find the expression that we want to. So in this case, b over a and a over b are reciprocals of each other. So we know their product it's 1, and we want to find the sum of their cubes. So firstly, let's see. Okay, firstly, let's see if we have an expression that relates for this. And it's the same expression as that we used before. I just realized that we were using the same identity in the previous problem and this problem. So actually, you can use the same identity we just used in the previous problem. It works. It works almost the exact same way. But right now I'm just gonna use another identity, so that we're making ourselves a bit more flexible, and we're using a range of things. So we know this identity. And I think I showed you in the previous video. Yeah. So that's the identity we're going to use. And you can use the other identity as I said before. But this one works as well. We're just using a range of things to get used to all these identities. So let's see what we know and what we don't know. So, and what we want to find. So we want to find this. I'll just make it distinctive. We want to find this. So we need to find this. Oh, and if we see here, these cancel out because this times this is 1. So this is neat, because all we need to find is b over a plus a over b, because they're on both sides, and all we need to do is find the values of these. And actually, I didn't realize, because I just wrote this randomly, to use a wider range of identities, but I think this is a much simpler technique than using the identity that we used in the previous problem, because we can see that we know the product, so this just disappeared, and if we just know the sum of those two numbers, we can straight away find the value of this as the sum of the cubes. So maybe if we use this identity in the previous problem, it might have been faster. But yeah, so if we caught that, then good job. But we can clearly observe that this identity provides an easier way for us, because we just have to find b over a plus a over b. But how will we find this value? Because we're given a really weird, strange identity, but we're gonna try what we can do. We're gonna try. So if we see if the given conditions, if the given expression, given value of the expression, if the given relationship seems to not be related at all to the thing that we want to find, then take that given relationship and do some stuff with it, because math problems aren't just given to you so that you can straight away see what to do. You have to play with it to make it so that you can see what it can do. You have to actually put effort into finding its purpose. So if we just rearrange that simply, we're gonna just see if we can rearrange it. If we can play with this to find something that will be useful in finding b over a plus a over b, or a over b. We might not even explicitly find this. So this will, if we just, so that means this, and then cross multiply, because we want to see where we end up. Oh, but then we see something good happen. So this is just b over a minus a over b is equal to 1. So the purpose of this relationship was to tell you that b over a minus a over b is 1. So actually, they could have just said this, but I guess the purpose is what the problem might have wanted to do was maybe it just wanted to just complicate the problem further, or maybe it just wanted to see if you were aware that maybe you could play with this to find something useful. So, but the problem is that we know b over a minus a over b, but we don't know b over a plus a over b. But remember, this is not the only thing we know. We know b over a times a over b is equal to 1. So we know the difference between the two numbers, and we know the product between the two numbers. So we're gonna and we want to find the sum of them. So the identity we're gonna use this time is gonna be actually, yeah. So this, if you remember, so I strongly recommend you to have the other videos open with you if you don't remember the identities, but you should be remembering them. So yeah, this identity, so this sum squared minus the difference squared is equal to 4 times the product, and this just cancels because it's 1. And so we know we want to find this, so b over a plus a, actually I write that in blue because that's working out. B over a plus a over b squared minus, this is just 1, so 1 squared is 1 is equal to 4. Therefore, b over a plus a over b is equal to root 5. So there we go. Actually, plus minus root 5, but I think the problem specified that a and b are positive, so that means this has to be positive. So b over a plus a over b is equal to root 5. So we're almost done, because we just need to plug this into here. So root 5 cubed is equal to b over a cubed plus a over b cubed plus 3 times root 5. So this is 5 root 5, and extending the 3 root 5 over here. I just realized and I didn't give any time at all for you guys to solve this problem, but I hope some remember to just try it on your own first. So therefore the answer is 2 root 5. There we go. So that was a bit more complicated because we had to continuously, actually it wasn't that much more difficult than the previous problem. I think maybe the only one thing that might have confused you guys could have been the strangeness of this relationship, this given relationship, and also like ending up with this and then wondering what you should do next. Because I think the point of algebraic manipulation, like the techniques I've shown, the main takeaway is not specifically just these techniques. But firstly, the identities, they're not just important in algebra, they're also very important in number theory because they relate different expressions, and if they're integer expressions, then you can know a lot more about divisibility, and that really helps in number theory. But more importantly is the fact that if you see here, like we always have to continuously dig out the things that we need. Like we will never explicitly see the thing that we wanted. We always have to use the things that we have to creatively use them to constantly dig towards the thing that we want. And we might be heading in the wrong direction. We might not even see if whether we're even heading in the right direction, like but the most important thing is you go in that direction, and if it's right, then you know that this kind of direction will be correct. And if it's wrong, then you'll know later on. The more you get it wrong, the more you'll know that the more you'll narrow down the range of techniques you'll have to use for any specific problems that you have to solve. And that is a very good skill. So I think practicing these kinds of problems are very important because there are a range of techniques you can use, but you are narrowing it down by doing many problems and getting better, more efficient and elegant and faster at solving these kind of problems. So I hope you enjoyed this video, and see you in my other videos.